chain rule today, let's differentiate the first one. dy over du. Good. Now, what would dy over du going to be? Yep. So, it doesn't have to be x each time, could be u. And how about dy over du for the second one? 3u squared. All right. Lisa, what's the next one? What's the next one? Yeah, okay, done. Okay, pretty easy. Okay, good. All right, so why do we do this? That's related to what we do. So, okay, next one. How do I multiply fractions? Okay, see these two are the same. They get cancelled. What do you have left? dy over dx. All right, it's all related. You got the du, right? So just like 2 over 3 times 3 over 5, right? The 3 get cancelled. Make sense? Yeah, okay, it works with polynomial as well. Oh, that one you can't cancel, they're stuck. These two are like super glued together. So they don't make sense individually. So the d doesn't mean it's a number. It's called dy over dx, the dy and the dx. Okay, all right? Okay. Okay, all right, let's move on. Okay, now how is that related? So what we do is, now as you can see now, what do we normally do? We expand, but we're not going to do that because what if it's 5, right? We're not going to expand it. So we want to know how to do this one. Okay, so what we do is this. We're going to, oh, that shouldn't be there. All right, let u, that's why I use u at the beginning, equal to 3x plus 1. So let the complicated bit be the u. Okay, this bit, right? So if I let this be u, what would the expression become? yu squared, right? So I've turned a bracket into one term. Yes? Okay, good. This is what we'll do next. Watch. We're going to calculate dy over du. We did that already, right? What's dy over du? 2u. Next, we're going to calculate du over dx. Let's do it. Oh, you purple. Du over dx. What's du over dx? Let me write it clearly. Sorry. Du over dx. What would that be? 3, right? Yes? Well, it's like if I write y over equal to 3x, dy over dx is 3, right? But the subject is now changed to u. So I write du over dx. Yep, okay. All right, and then what we do is, we can use the first rule. Dy over dx is same as dy over du multiplied by du over dx, right? Because the du get cancelled, we saw earlier. Remember this? That becomes dy over dx, right? dy over dx is dy over du times du over dx. Remember, we just found that they cancel, become dy dx. Now, what's dy over du? 2u. What's dy over du over dx? 3. So you get, what do you get? 6u. Now, what was u equal to? 3x plus 1. And if you expand it, what do you get? Yeah. Now, how do I know if it's all right? Let's expand it and see if we get the same answer. Yeah. Let's expand it. So, let's do it the long way. Or maybe the short way, because it's easy to expand. If we were to expand this, which is equal to 9x squared plus 6x plus 1, and if you dy over dx, I mean, this is, of course, much faster, isn't it? But it's not going to be fast when I do this, isn't it? I could still use this method for power 5. So this is just a way to see the method actually work. For small powers, it should work with high powers, right? So we use this method again. All right. That's why this course is called calculus, because we learn a lot of calculating methods, calculate different derivative. Okay, all this calculus, it's a set of methods you're learning how to differentiate. All right, how about the next one? Let's try the next one. What's the first step? Let u equal what? 4x cubed, whatever's inside the power, right? And then we're going to do, right, y equal to u to power of 5. And do dy over du. What do you get? And then we'll also do du over dx. What would du over dx be? 12x squared. And then we multiply them together. Because why do I multiply them? Because dy over dx is same as dy over du multiplied by du over dx. Yes? And dy over du is this thing. Du over dx is this thing. And remember to replace u back in terms of x. So let's times them together. 5 times 12 is 60. X squared u to power of 4. And what's u? What's u again? U is, yes. And don't forget to power 4. See, it's the same amount of work, but without expanding. See, if I expand that, that will take a long time. Not to mention you're going to make a mistake. And of course, this course don't expect you to expand this. It expects you to use this method. Okay. All right. So, no, we found the derivative. That's dy dx. Yeah. Okay. Now, no, you don't need to. Now, how are you going to expand to power 4? I mean, this one I expand so I could compare with this one. In fact, this one you don't need to expand. You can keep it like this. I just expand it so that I could compare with the old method. Whereas this one, I can't compare it. You don't expand yet. Don't expand after you use this rule. This is called the chain rule. Why is it called a chain rule? It's like chain reaction. You do the u first and do the next. Do the dy du, then do du dx. Right? It's in chain. Does that make sense? All right. Now notice that I left a column here. I could show you even a quicker way. Even a quicker way. Because I want to, well, that's the, explains it. This is the formal way to do it. We can take a shortcut, an even faster shortcut. Okay, let me show you how it works. All right, let's go to see this column here. And that's the method I want you to use because it's much easier. Yeah, because it's same as this one, except that we don't have to write out a lot of things, right? We don't like to write a lot of things because it's hard. Okay. Good day. I'm good. Yeah. Okay. All right. Now watch this. Now remember, I let u equal to 3x plus 1, isn't it? So I'm not going to let u. I just do it. Just pretend this is u, right? So when you do it, write dy over dx. Pretend this is u. Right? Does that make sense? So you just pretend this is u. Like, remember I wrote 2u before? I write to this without making substitution. And then what's the next step? I also have to differentiate the u, right? So if I differentiate this, what do you get? Yeah, it's the same thing, isn't it? Can you see it cut down a lot of writing? Yeah. Because why I do it this way, so you know where the u come from. If I just do that straight away, you see what's going on. You don't see the structure. Now you see the structure is that you're actually differentiating the u square, right? You pretend this is one object. You differentiate it as if it's x, right? Let's do the other one. Let's do the next one. Okay, y equal to 4x cubed squared to power 5. Okay? dy over dx, again, pretend this is one person, one term. This is u, right? So what do you write? 5 something to power 4. Does that make sense? And then whatever's inside cannot change. Has to be the same. That remains the same, right? It remains as u. And what else you have to do? Differentiate that, which is 12x squared. Can you see the same thing? Except I don't have to do a lot of writing. And then you continue. What's that? 5 times 12, 60x squared. Right, that's your chain rule. That's why it's called chain. You go the outside first, then the inside, right? Does that make sense? Now, on the next page, there are 6 questions for you to do. If you can do them, you should be able to do the homework. Yeah. Oh, do you prefer the first way? All right, it's up to you. That's why I give you both ways. Yep, everyone's have different preferences. It's okay. It's okay. So these are the working. You can use both ways, okay? But I'm going to keep using this way because I can't stand, I mean I can, but I think it's going to be too many writing, okay? So, yep. Of course, that's what everyone do, the short way. Most people, I don't think I've seen someone using this in exam because it just takes too long, okay? Yeah, and then times by the derivative. Yeah, I think that's more procedural. So, yeah. Yeah. Okay, all right, have a... Okay, let's do it. Now, how about this? Watch me how I use the method 2. If I do a few more, you won't get confused. Okay, so let's say I do this. So I just write y equal to that. Just do a couple more, you'll find that the second one is much quicker. You won't get confused at all. Okay, dy. Yeah, of course. Oh, y dash. Yeah, I just think dy dx is more professional. Okay, so 5. Now just pretend this is one term, right? So when you do it, just write 5 times -4 to the power of -5, right? And remember, what's inside does not change, right? I'm just differentiating the outside. And once you do that, differentiate the inside. What's the derivative of the inside? 3. Yep. So I can't see that will be confused. But you just a matter of practice. If you do a lot of practice, you won't get yourself confused. Yeah. I think when you do the other way, let u equal to whatever, that will get confusing because you do more writing and you get confused. But anyway, let's continue. What would that be? 60, right? Right? So 60? Yeah, 20 times 3, 60. Yeah. Okay, next one. Okay, let's do this. Let's do y dash. Okay. So how does it work? Now remember, you bring the 5 down to power 4, right? Just pretend you differentiate x to power 5, right? You bring the 5 down, subtract by 1, you get 4. And remember, whatever is inside does not change. Yes? That has to stay the same, identical. And you must remember to differentiate what's inside. What's the derivative of inside? Yeah, so this time I need a bracket, isn't it? Because it has 2 terms. See, this one I don't need a bracket, it's just 1 term. This one, there's 2 terms. I think that's all. There's not much. Or you can take the 2 out if you want to. I think it's good to take it out. So you get 10, 3x plus 1. Oh, you expand and I prefer you factorize. Factorize better. Yeah, but even if you write 30x, you still have to factorize. Yeah. So you write 2x, 3x plus 1. Yeah. Hang on, sorry. I prefer you to factorize. So you write 10, 3x plus 1, then 3x squared plus 2x plus 5, power 4. I should make it 2 columns and then make it wider. Oops, yep. Which one? Yeah, let's try to do it. So, all right, quick. That's your final answer. All right. Oh, this is super bright. Very good. It's brighter than my laptop. Okay. All right. Okay, good. Hopefully it's okay now. Let's do the next one. Okay, the next one is, just need to write it like this. Write 1/7 in front. What order? Oh, yeah, I prefer to put the small one first. It doesn't matter, but because if you put a small bracket at the end, it just look awkward, right? I don't know. It just that sometimes it gets forgotten, right? So put the small one in front for a reason. Okay, good. All right, next question. All right, let's do y dash. So you just bring this 5 down. 5, 3 minus 4x power of 4. And then, right, bring the 5 down, subtract the power by 1. And then you also have to differentiate what's inside, which is -4. Oh yeah, -4. Did it answer your question, Anthony? You write -4. Oh, times by -4. There's no x because after you differentiate it. Because when you differentiate 3 is 0, differentiate -4x, you get -4. And what do you get? -20/7, 3 minus 4x power of 4. Yeah? Yeah, you leave it as a fraction, yeah. Because otherwise that's a decimal. You can't round it. That will be not exact. Well, that's the thing that I still get in the exam, which is a wrong thing to do. It's almost like this. Okay, I want to calculate 1/3 minus, let's say I want to do like 1 minus 1/3. Does that give you, is that the same as 3 minus 1? If you times everything by 3? Does that make sense? That's what you're trying to do now. I mean, if it's an equation, yes, you times everything by 3. But you also times that by 3. There's 2 sides to it. This only got one, this is one-sided, not two-sided. Does that make sense? Yeah, so they're completely different. Okay, let's move on. Okay, next one. All right, first step. What's the first step? Write in index form. What would the just y. So before you differentiate, make sure you write it in index form. What would the index form be? Yeah, that's your first step. Then do the y dash. So y dash is bring the half down and then subtract the half by 1, which is negative half. First step. And don't forget the chain rule. You have to differentiate what's inside times by 3. And what would the answer be? 3 over 2. Now make sure you do it slowly, just step by step. Just keep it negative half first, before, so times the 3 by half. Then write it without negative indices. So you write that as 1 over 3x minus 5 to power half. Yes? And after you write 1 over, you write 1 over square root of 3x minus 5. Notice I do one thing at a time. And then you put the 3 on top and 2 at the bottom. Okay, any question? Good. Try the next one. What would the next one be? Let's try it. Okay. We'll write y there. So what you do is you write 3 times 1 over x plus 2, and then you write it as a negative index. Yes? That's just your first step. This is still y. Then we're going to do y dash. Y dash is negative 1 times 3 is negative 3. X plus 2, negative 2. And then what else you have to do? Differentiate what's inside, which is 1, which is just nothing, right? So you get negative 3 over x plus 2 squared. Alright, good. Got one more question. The last one is a little bit harder. Now minus 2 because it's subtract by 1. Yeah? So negative 1 minus 1 is negative 2. Yeah. Okay, try the next one. Zoom out. Okay. Alright, try the next one. What did you do? Yeah, negative half. Yeah, so if you do it in one step, you just get this straight away. Yeah. Yeah, but if it's at the bottom, yeah, if it's bracket means there's no power 1. Yeah. Half, yeah. Okay, we did that, do y dash. So do 4 over 3 multiplied by negative half. Four over 3 times by negative half. 9 minus x to the power of negative. If you subtract by 1, you get negative 3 over 2. Yep. Differentiate what's inside, which is negative 1. So what do you end up getting? You get 2/3, right? You get 2/3. And once you do that, write it with that index notation, write it in insert form, if possible. So you times by 1 over 9 minus x to the power of 3 over 2. And then you can write that as 2 over 3. The rule is cube root or square root of 9 minus x cubed. Okay. So I'm just applying this rule. If you have, say, a to the power of m over n, it's equal to the nth root of a to the power m. Yeah. 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 So no, this times this, you get positive. Oh no, the power doesn't get multiplied, no. No. Yeah, it's like this, negative 1 times x squared doesn't become x to the power negative 2, if you know what I mean. Right? Yeah. Okay. Alright, it's all done. Okay. So this can be a challenging exercise, but if you start now, you'll finish before the bell goes. Alright, thank you. Now, Q.